Okay, so here we have this weird graph. So we have f of x, and it's not anything like the parent functions, but we have something that to work with, and what we want to do is sketch this. So so we're just gonna go ahead and just jump right in. So remember that I always want to start from the inside out. Okay, so the first thing that I want to do is shift this 3 units, and this is going to be 3 units to the right. So 3 units to the right. So basically what I'm doing is that this entire graph is going to be moving 3 units that way. Okay, so let me start off. And in this case, it's all horizontally, so it's all the x values. So right now, this x value is at -2. Okay, so right now it was at -2. I'm going to move it, and here it's at -3. I'm going to move it 3 units to the right. So it's at -2. I'm going to move it 1, 2, 3. So now it's at -1. Okay, so it's going to be right there because initially it was right here, moving it 3 units, and it's going to be there. Okay, now let's work with the next one. The next one's going to be this 3 right here, the 0, 3. So that guy was somewhere, let me write it like this. So that guy was like right there. So now what you're going to do is you're going to move this guy 3 units over. Okay, so moving this guy 3 units over, oh, this should be a 1, not -1. Moving it 3 units over is going to be 1, 2, 3. Okay, 3 units over, right there. Okay, now this guy right here is at 2, 0, which was right here. Move it 3 units over, 1, 2, 3. It's now at 5. Okay, and finally the last one was at all the way up to 4, and then at 5. And I'm going to move it 3 units over. 1, 2, 3. Now this is at 8. Okay, so it looks like this. Okay, so let's see if I drew it correctly. So they should still have the same shape. All I just did was I just moved it over 3 units to the right. Okay, so that's what it kind of looks like. So still same shape, just shifted it over 3 units. Now the next thing that I'm going to do is I'm going to, so I did this guy, now I'm going to do the 2. So I'm going to multiply all of my y values, because remember f of x is just the y's. I'm going to take all of my y values that I have right there, and I'm going to multiply it by a factor of 2. Okay, so let's see what this is going to be. Oh gosh, here we go. All right, so this guy right here, which was at 1, -3. So at 1, oh, let me write it a little bit better. Okay, so it's at 1, -3. So what I'm going to do is I'm going to multiply the -3 by 2. And that's going to give me -6. So instead of that, it's now going to go now to -6. So instead of being here, it's now going to be down here. So I'm stretched it all the way down. Okay. Now I'm going to go to the next point. The next point is going to be this guy, which was at 3, 3. 1, 2, 3. 1, 2, 3. Okay, so it was at 3, 3. This 3, I'm going to multiply it by 2, which means I'm going to stretch it all the way up to 6. 1, 2, 3, 4, 5, 6. Okay, so now this guy, instead of 3, it was at 3, 3. Now it's going to be at 3, 6. So all the way up there now. Okay, so it's stretched significantly. Now I'm going to look at this guy, which is going to be at 5, 0. 4, 5, and then 0. I'm going to multiply this y value by 2. Notice that it's not really going to do anything. It's just going to stay there, because 0 times 2 just gives me 0. And then finally, I'm going to do the last one, which is going to be this, this 8, 4, 5, 6, 7, 8, and then 4. So that's where that guy was at. I multiply the 4 by a 2. That's going to give me 8. So this guy, instead of the 4, is going to go all the way up to the 8. So this guy now looks, it's stretched up. So you can see that now this looks a lot more stretched. Okay, and now finally, what we're going to do is shift everything up by 1. Okay, so now everything is going to be increased by 1 unit. Okay, so So starting with this point, instead of -6, now it's going to be up by -5, and it's at 1. This guy right here, it was at 3, 3, 6. I'm going to shift it up 1. So it was at 3, 6. So now it's going to be at 3, 7. Shift it up 1. This guy was at 5, 0. So 5, 0. Shift it up 1 is going to be at 5, 1. And then this guy was at 8, 8. Shifted up 1 is going to be at 8, 9. 5, 6, 7, 8, 9. So now this guy looks like this. And that's the final answer. Pretend that it didn't go that way. Okay. All right. So as long as you take it step by step, it should be pretty easy to do. Okay. Now we're gonna end this video with something with graphing the piecewise functions. Now that we kind of have an idea of what the parent graphs look like, so we're gonna sketch a piecewise function. So if you remember, a piecewise function is just a function in various pieces. So if I have f of x, you have x squared, 3x. I'm just giving you an example. If x is less than or equal to 1, if x is between 1 and 2, and then if x is greater than 2. Okay, so you have something that looks like that. So now what you want to do is let's go ahead and try to graph this. Okay, so the way that you do it is I like to write it out in different intervals. So we see that you have something that's less than 1, completely less, somewhere that's between 1 and 2, and something that's beyond 2. So you basically have 3 different worlds. You have a world here, and then you have a world in the middle, and then you have a world in the outside. Okay? So now you have to think about a couple of things. So what I like to do first is I like to draw the endpoints. Okay? So at x squared, when I plug in the 1, okay, so let me start off with the endpoints. So at x equals 1, there's a couple things that I'm going to plug in. I'm going to plug in the x squared, okay, because there's a 1 in the x squared. So here's x squared. I'm going to plug in the 1, get 1 squared, which is 1. So when x equals 1, I get a 1. Okay, now for this x squared, is it included or not included? It's included, right? Because there's an equal sign there. So that guy is going to be included there. Now, do you remember what an x squared looks like? Well, an x squared just looks like a parabola, right? So it looks like this. Okay, so it starts at the origin, and then it's 1, at -1, there's 1. So it kind of looks like this. Okay, so remember that this graph is going to continue on everywhere that's less than or equal to 1, right? So everything that's less than, which is all of this guy, is where the parabola exists. It's not going to extend because that's where the parabola ends. The parabola ends at 1, okay? Because after that, you have a new function. So that's done. So the parabola is now done. Now, we do still have to check what happens here. So in the second part, you see that you have a 3 if x is between 2, x and 1 and 2. So what does y equal to 3 look like? So that's just a constant, right? So it looks like this. So it's just a constant line that looks like this. Okay, but it's not defined everywhere. It's only defined in certain points. This graph is only defined from 1 to 2. So at 3 here, at 1, and then going up to 3, this is not included. Okay, and then I'm including the 2. So this graph looks like this. It's just a straight line. Okay. All right, and now finally you have y equals x. So if x is greater than 2. So what I like to do is I like to plug into the graph, into the x. So let me plug in x equals 2 into x. Well, all I'm going to get is just 2 when I plug it in. So that means when x equals 2, y equals 2. So y in this case is equal to 2. Okay, now is this included or not included? It is not included. Okay, now pick something else. Pick something else that's greater than 2. Okay, 3. Okay, so when I plug in 3 in here, I'm just going to get 3. So when this is equal to 3, I'm going to get another 3. So that means this guy is going that way. Okay, and this is basically what you want to be able to do. So you kind of want to be able to break it up into different types of intervals and then graph them like as so. So let me give you another example. So let's say we want to graph this. And then okay, so let's say we have something like that looks like that. Now, the good thing about this is that they're both lines, so you don't have to worry about curving it or anything like that. But let's start off with where exactly these guys are breaking up. So they're breaking up at 1. Okay, so I'm going to take the graph and then look at 1. And what I'm going to do is I'm going to set it up this way. In this direction, this is everything that's less than 1. And in this case, this guy is going to be everything that's greater than 1. Okay? All right, so now let's go ahead and take a look at it. So let's look at everything. Let's see what's happening at 1. So at 1, let's check what happened. So notice that both of them have a 1. Some of them are included, some of them are not. So let's start off with the 3x plus 2. Okay, so let's start off with this guy. So I'm going to plug in the 1. Okay, so I'm going to plug in the 1, and I'm going to get 3 times 1 plus 2. That's going to give me 3 plus 2, which gives me 5. So at x equals 1, I get a 5. 1, I get a 5. Let's say this is 5. Now, at this point, is this included or not included? It is not included, so I'm not including it. Okay, so there's a big fat circle there. Now, look at the restriction. The restriction for this function is that it's greater than 1. So we're only looking at this world. Okay, so we're going to look at that world. So let's pick something that's greater than 1. Okay, something that's greater than 1. Let's pick 2. Okay, so I'm going to plug in 2. So I'm going to have 3 times 2 plus 2. That gives me 6 plus 2, which gives me 8. So when x was equal to 2, I'm going to get an 8. So let's say 8 is up here. Okay, and that one's included. So that means this graph is going to go upward like that. Okay, now let's look at the other one. So at the other one, you have negative x minus 3. So let's first start off by plugging in the 1. So I have 3, oops, that's wrong. So I have negative 1 minus 3. That's going to give me a negative 4. So when x was positive 1, I got a negative 4. 1, 2, 3, 4, negative. Now this one was included because there's an equal sign there. So we're going to put a closed circle there. Now notice that we want everything that's less than 1. So we're in this direction now. Okay, so let's pick something that's less than 1. Well, the one that's less than 1 is 0. So that's the easiest number. So x equals 0. So we're going to plug in negative 0 minus 3. That just gives me negative 3. So at 0, you get a negative 3. So this one is going to be going this way. Okay, and that's the graph of the piecewise function. Okay, so you want to make sure that you take this with care and graph each piece where it actually lives.